Hi there! In the previous episode, I made the introduction to using scopes in Hanami 2 applications. Today, I will dig a bit further and leverage the parts feature. So, if you are not familiar with this, I would recommend visiting the guides first, or checking out my previous episodes on these topics. Today, I want to tackle the logic extraction from complex forms in Hanami 2, step by step. And because of that, it can take a while, so please prepare yourself for a longer episode. I have here the registration form I have created for rendering the Flash messages tutorial. However, it's not fully functional yet. It contains a couple of fields only, but you may already see that it's pretty bloated piece of HTML that is supposed to mix quite a bunch of rendering logic in it. For example, if there are errors in a particular field, the input should be highlighted with a red border and the exclamation icon should be added to the right side of the input. Additionally, below the input, there should be the exact red notification about what's wrong with this field. Today I want to do the challenge to extract this logic and refactor the code, so it's easier to work with the dynamic data we have here. Let's start then. Before we do anything, let's make sure we can properly render the field errors. For that purpose, I'm going to visit my create action and add the custom view rendering line here. By default, the create action will render the new view, with the request parameters being accessible, so the form can preserve the field values we passed in, except password fields, of course, which are filtered out. However, because we want to add the errors to work with, let me render the view manually. Now in the view, I can make use of this to expose the form object I would like to work with in the templates. I will make it dependent on the values and errors input arguments, but will set defaults for them so the new action can render the view without passing any parameters into it. Then inside, I will return the hash that merges those two together and will decorate this value in a moment. By default, to decorate this, the parts form class would be used. But because this is the only form in my app right now and the common patterns haven't emerged yet, I will make this more explicit and paste the custom part class in the options. Now let's build this part. I'm going to create a new part file and inside add the errors method that allows me to list the error messages for a particular input field. So I will be able to list those below the form's entry. That's enough for now. Let's use it in the template now. Under each field, I'm going to paste the line that will render the field error messages and paste that message as local. Then I only want to render errors if there is actually an error message. I also need to add a dynamic class names for the form if the field errors out. By the way, I know there is a logic here. I'm doing things step by step so you won't get lost in my thinking process. When I copy these field implementations over, you will see that the only thing that changes here is the field name, and that's already a pattern for me. Then I will add the field errors partial. First, I'm going to render the exclamation triangle icon span, and then for each of the provided messages, I will add the properly styled paragraph, one under the other. The form now should render errors for each field. Voila! That's the basic level. Now, let's go to level 2. All those fields are very similar. The HTML part is different, but the logic inside is just the same. all they need is a form object to render the field values correctly. Information if the error is there. Error messages, icon name, attribute name, and maybe custom label text, as you may see in case of the checkbox here. So the first step will be to normalize our partials. Let me then extract the fields to separate field-based templates. I'm going to create a separate template for each field type in the shared forms directory and paste the code inside, simplifying the logic a bit. First, I want to create the text field template. I want to remove the username and replace it with the general field name local. Then I want to be able to pass down a custom label text if that's needed. The icon here should also not be hard-coded, but rather set dynamically. Now let's look at error checks. There are two places that check if the field is an error. So let's extract this out too. It comes with setting up dynamic set of classes for the control field that can be extracted to a variable together. Next, let's tackle the error messages to not be dependent on the field name at all. You may notice here that the if statement is left here to render the errors partial. And I don't know how about you, but for me, it's logic in templates for sure. However, I have already shown the other approach to render field-specific errors in forms in the episode 46 about the contact form. So you might as well check that out. And here I will just leave it like this. Finally, let's take a closer look at the first class names. There are custom classes added if there is an error, but also if the icon is set. Without the icon, we don't need the hasIconLeft class, which makes the list of classes even more complex. Let's extract this out too. The span class should also be conditional, based on the fact that the icon is present. We already discovered a bug in our code. Isn't that cool? Let me then extract the icon span into a separate partial. Let's render the icon passing down the name as a local and the alignment information. Then do nothing if the icon should not be set. I will create a new partial named field icon, and inside I will paste my span, replacing dynamic content with local variables. The icon name local I will rename to icon. I can also replace that when rendering the partial. Next, let's go to the field errors template and also change the hard-coded span tag to just render the icon partial. Oh, I see I have named the icon partial wrongly. Let me quickly rename the file to field icon and reflect that in partials that call it. Now it's fine. Finally, let's take a closer look at the input field. I want to have an extra class added in case of an error, so it gets the red highlight. I will extract it the same way as I did for the wrapper leaf. When I think about it, I can even add a dynamic placeholder support. Let's also allow this to be passed in. Phew, done! But that was crazy. I hope you can see now how much logic is hidden in each template, or at least in most applications. And with this knowledge, we can together make the world a better place by extracting all of that out. I know this is a lot, but by extracting this, we can copy the partial and easily adjust it to a password field, email field, or anything else. I will quickly write down the checkbox field here yet just to verify if I need any other dynamic data. No, it seems I needed even fewer methods. Cool. So the next step for me is to write the form input scope that will accept the different inputs and resolve the local variables in a way understandable for an input field partial. In the new scope file, I'm going to paste down all the logic I have extracted from my partial and then wrap them up with the nice Ruby methods. The field name will just call super and stringify the value so we can pass in symbols as well. Label text should be optional, so if there is no label attribute passed, we will return the humanized field name. Let's skip the icon name for now, and to decide whether the field is error, we need to check errors array. And we already ensure that this will be an array, so let's write this down. Next we have control class names. First I need to have the default value, add the icon class if error has an icon, and error if it has an error. At the end we join the classes into a single string. This means that in the test field partial I can remove the first part of the control classes and just rely on the variable. Going back to the scope, errors will be just passed as arguments, so we don't need it. After that, I implement the input field classes method similar to what we have in the control tag. And for the placeholder, I will again return the passed in argument or fall back to default calculated on the field name. Okay, we have now an amazing class that we can unit test and that can guarantee that our partials will be rendered correctly. There is a big caveat here though. If I go to the form template, replace my input by calling the input scope with some attributes, and then render the exact template, it does not look much better, does it? It's because this code does not belong to a template. Hanami provides us with parts as a way to decorate our exposures. And all the data we need to set this up we have on the form exposure, except the form builder. So I could replace this all with just form.username scope passing the form builder as an argument. Or instead of returning the scope from the partial, I can even hide the rendering inside the parts method. I will go with the latter approach, though I'm not sure which one is better yet, as those concepts are just too new. I'm looking for your feedback on this. Now let me create the missing methods in my parts. In my registration form part, I want to have a method for each input field that accepts the form builder. Then each method will render the correct field type with a separate scope prepared. Again, the actual rendering might belong to a template, but I guess it's just a preference. As long as we are consistent, we should be fine. The field name here will be username. The scope will be always the same, so I will extract that to a constant named scope class. Then I can repeat that for the remaining scopes, form fields, with minimal changes. I need just a field name to be changed and the partial name to be rendered. And the rest is just the same except the TAC field. Before that though, let me clean this up a little bit. I will move the errors to the private section as this won't be used anymore from the template. Then I'm going to set up the correct icon names for all fields. Now to the terms and conditions field rendering. Only this field needs a custom label that I need to prepare and paste that as an option parameter to the scope. Now that drives us again to the template where we can replace the complicated HTML with our part methods. This cannot be more clean. You will miss the password field partially yet, but that's identical to the text field, except the method used on the form builder, so I can prepare that quickly before running the app. Let me check now what happens in the browser, as I have written quite a bunch of code at once. Okay, there is an error saying that the icon name is called, but it's not passed into the scope in one call. Let me check. Oh, it's because our checkbox has no icon passed. But I still call this method on the conditional. I will just make it optional for now. Can be solved in the part, but that's fine for now. Now, the form works flawlessly, as before, but our template is as slim as one can imagine. Working with templates is a hard job, and eliminating the logic out of them is absolutely not trivial. Hanami provides us with a bunch of tools that helps us maintaining this complexity and keep our templates always simple and clean. But there are still multiple trade-offs. You always need to balance between how simple and skinny your template is and how easy it is to update by front-end developers, which means how much Ruby code links to it. I hope that this and previous episodes about the topic show you different approaches and you will find them useful. If you want to see more content in this fashion, subscribe to my YouTube channel, newsletter, and follow me on Twitter. Now I want to especially thank my recent sponsors, Adrian Marin, Lucian Ginda, and Maxim Gurin, and all the Hanami Mastery process subscribers for supporting this project. I really appreciate that. If you want to support us, check out our GitHub sponsors page or join Hanami Mastery Pro as mentioned just before. Thank you and have a happy rest of your day.